Okay, we're recording. Good. All right, here we go. Square. When I showed you the quadrilateral tree, where was the square? At the bottom of the parallelogram family, right? And I connected it with the rectangle and the rhombus. All right, not to try to be funny or anything, but the square is like the golden child. I don't know. Maybe some of you can relate. I obviously can, but it happens. All right, in the family, my sister got the shaft, so it happens. It's hard to live up to this anyway. Square's got all the properties we've talked about. All those parallelogram properties, all those extra rectangle ones and extra rhombus properties, square's got them all. Got them all. I have two listed here. You know what I'm going to write? All rectangle properties. All rhombus properties. All right. Now, I only put one definition up there. It's a rectangle with two congruent sides. I want you to put a second one up there for me, and I'll start it. A rhombus with what? A rhombus, or it could be a rhombus with how many? Do I need all four? I only need one, so it could be a rhombus with one right angle. All right, and that's good to know when we start graphing them in a second. All right, hope you're breaking down a radical skills are up to par, because that's what we're about to do. Here you go. Length of a diagonal of a square is 16. What's the perimeter? Oh, boy. Okay, diagonal is 16. Got it. What is the perimeter of the square? There's a lot of ways we could go about it. I want to hear about you guys. I'm telling you, it's got all the properties. So what do you know about all the sides? They're congruent. So I need to find one, multiply it by 4. You got the perimeter, but you got to get me to a side first. Help, help, help. I need help getting to a side. I know this is 16. All properties we've discussed, because there's multiple ways of doing it. I just want to let you guys have some flexibility here. Hello, Maggie. You're darn right I can. No matter how I do this, it's going to be Pythag at the end. Yep. So okay, so I'll put x and x. How about that? So x and x, yep, and this is 16. Okay, and this is just to make sure we're involved in a right triangle. This is a right angle for a square. Okay, so I can set up Pythagorean theorem. A squared plus b squared equals c squared, yep. So the two legs, Maggie, you said again, were what? X squared plus x squared equals 16 squared. And this drives me nuts, this next step. Don't even say it. X squared plus x squared. Okay, it's not x to the 4th. That's multiplication, all right? We're not multiplying. Yes, you have how many x squareds? 2x squared, 16 squared. 256, everybody. Okay, keep going with me here. Next step, divide by 2. X squared is equal to 128. That is not a perfect square, though, unfortunately, as some of you can find out right now on your calculator. But I would like it to be simplified if possible. So let's try to find the biggest perfect square right now, everybody. That goes into 128. And 4 is not the biggest. Keep going. I don't think 16 is either. Keep going. It is, what are we finding? 64, yes, 64 and 2. So what is one side length here? Square root of 64? Yep, 8 radical 2. That's just one side length. I asked for the perimeter, so I can take 8 radical 2 and multiply it by 4. What can you multiply up there? The 8 and the 4. So my perimeter, 32 radical 2. Now, hold on. I did mention another way. I don't know how many of you liked or preferred this way, but ready for the other way? How many diagonals does this square have? Well, you can draw both in. All right, let's talk. Since it's a square, what do you know about the diagonals? Bisect each other. So I really could go 8 and 8 here. And they're congruent, so these are 8 as well. What do you know they form? It's also a rhombus, so they're perpendicular. And then does everyone see how you could have done 8 squared plus 8 squared equals c squared now? And then broken that down. So that's the other way, is put in both diagonals instead of just one. Questions? All right, you ready to do a coordinate one, proving it's a square? All right, let's discuss how we want to do it as a class. You'll have a lot of time to be flexible on your own tonight with the homework. You do have to start this by either saying it's a rectangle or a rhombus. You cannot, there is no way you can go right to square. All right, so what do we want to do, rectangle or rhombus? Rhombus, I figure that because what do you just have to do to show me it's a rhombus? Oh, you can, but you better show me it's a parallelogram first. And I really don't want, I don't think you guys want to go parallelogram, rhombus, square. How do I show it's a rhombus right now? All 4 sides congruent. Okay, if you just show me 2 sides, that's not going to be good enough. Got to show me all 4 sides congruent. What formula am I going to need? Distance. All right, go ahead. You and your groups right now. Distance. So we're going to prove it's a rhombus first by doing distances of all 4 sides. Okay, I'm seeing a lot of this now, and you can do this now, but I'm telling everyone it's not going to fly on the test, is that you find the first side to be 5, and you know all the other sides have to be 5, so you just write 5 down. All right, you have to show me the numbers you're plugging in, please. Okay, that's not going to fly with me that you found the first side was 5 and then, oh, everything else has to be 5. Quick, 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 5, 5, 5. Nope. Show me the numbers. Prove to me it's 5. Prove to me it's 5. Whether that's by distance or Pythag. Those just appear out of nowhere. Okay, I'm just saying. Hopefully it doesn't hurt you on the test. We all getting 5 out. All right, next step is not telling me it's a rhombus. You're telling me what you just learned from step 1. What'd you just figure out from step 1? QP is congruent to QR, also congruent to RS, also congruent to SP, not because it's a rhombus. We haven't shown that yet. Why are they all congruent? What did you just show, Vincent? Yeah, distances are equal. All right, next up. If all 4 sides are congruent, you at least have a what on PQRS? PQRS is a rhombus. Because, why is it a rhombus? All 4 sides congruent. All right, now how do I make this into a square? There are 2 different ways I can make this into a square. Find one right angle, or what else could I show with the diagonals? What do you know about the Here's a rhombus. What do you know? I got to find a property that the diagonals don't have in a rhombus that do have in a square. I already know they're perpendicular. It's a rhombus. I don't have to show that. I could show they're congruent. Okay, so either we can show the diagonals are congruent, or one side or one angle's a right angle. Where are we going? Okay, so we're going to have to use what formula? Slope. All right, pick 2 sides because you don't need to do all 4. Because you don't have to find all 4 slopes. All right. What do you want? Slope of? There's no wrong answer here. What do we find the slope of? Because SR, and that would mean we'll have to find the slope of either PS or QR. QR it is. You only have to do it for 2 of them because I'm looking for one right angle. So SR, rise over run. QR. Three-fourths and -4/3, yes. That's fine. Because you graphed it. So I'm hoping you used your graph. Yep. All good. All right. Step 5. What did we just learn? What's this tell you? If one slope's 3/4 and the other's -4/3. They are negative reciprocals, which means SR and QR are what? Perpendicular to each other because slopes are negative reciprocals. Nice and organized, hopefully. Okay, if they're perpendicular, what's it create? Where? And specifically on this one. If we did SR and QR perpendicular, that's a right angle at angle R. Yep, angle R is a right angle. Because perpendicular lines form right angles. All right, here you go. We got a rhombus with the right angle. Makes it a square, finally. Squares are a beast to prove. PQRS is a square. All right, I'm going to turn it over to you guys. Why is it a square? Got to say it's a rhombus. Can't just say it's got a right angle. I could show you a trapezoid with a right angle. All right, it's square because because rhombus with one right angle implies a square. Yeah. How about that one, huh, kids? Yep. Anything here? What I need to show first? Are we getting? Answer me honestly here. Are we getting a little bit better at these types of proofs? What I'm requiring as far as the detail goes. Okay, we all good here. I like them because it gives you a lot of flexibility. Some of you may not have been able to relate with the square in your life, but definitely the next one, probably. Karma, Mr. Carlino, karma. Yep, the kite.
Pinwheel. Slide diagonal.
Comes from the corner, genie. You've never seen that one. Oh, all right, well. All right, let's go. Right, let's get going here. Any others here? Because we got to get moving. Voting, anything? Okay, curtains. Cube. Shatter. Shatters. Flips. Star. Pinwheels. 6, 7, 8, 9. Slide left. Curl. Slide right. Okay, ready everybody for pinwheels. Oh, sorry, genie. Pinwheels, everybody, pinwheels. So it just goes and starts turning. Pinwheels or Promethean Man, we all set. This could be a big no homework here. Here we go, ready? My God. Why? This is somehow rigged. It really is. This is somehow rigged. Okay, here we go. That was Genie right there. That was Genie. Well, usually I went backwards, but usually when I go forward, it comes from the corner and comes out like that. All right, here we go. Let's just get this finished now that we have no homework once again. Thanks for the pinwheels, people. All right, here we go with the kite. If you remember where the kite was, it was totally on the opposite end, all by itself on the family tree because it had no opposite sides, parallel. Okay, it has no parallel sides, but it does have, for its first property, as you can, I've already marked your diagram, it's got two consecutive sides, two pairs of consecutive sides congruent. Well, how's that different from a rhombus? Because a rhombus has two pairs of consecutive sides. Yeah, and there's no opposite sides congruent in a kite. Okay, there's no opposite sides congruent in a kite. Two consecutive sides congruent. All right, next one is one pair of opposite angles are congruent. And the concern I always get, well, how am I going to remember which pair? All right, no matter how it's drawn, does everyone see where the two non-congruent sides intersect? Do you see the angles formed by the two non-congruent sides? In my diagram, what angles are those that are formed by the two non-congruent sides? Angle B and D, those are the opposite pair that are congruent. The other pair is not. And there's a reason why they're congruent, which we'll go over in a second. Everyone good so far? Because now we're going to introduce these. AC and BD. Those diagonals are perpendicular. Well, they don't look congruent, and they're not. Diagonals are perpendicular. And finally, I don't just want to give this one to you, but everyone see these two triangles up here I've created? Okay, those triangles, if I count this as a reflexive side, are congruent by the HL method. Do you see the HL method? Hypotenuse right here, the leg, the reflexive side. They're congruent by HL. Why do I tell you that? What do I know about these pieces now by CPCTC? They're congruent, which leads me to our fourth and final property, which is the longer diagonal does what to the shorter one? Bisects it, yes. Longer diagonal bisects the shorter diagonal. All my energy just goes out the window when you guys guess it correctly. So bitter. It's happened so many times too. There you go, everyone. The forward genie. Have you ever seen a genie, Teddy? I don't think any of us have. You've never really seen it come out of the lamp. All right, moving on. Okay, here we go with the kites. Find the measures of the numbered angles. Get the calculators ready. Looking for angles 1 and 2. Before we find angles 1 and 2, any fact about angle 1 and 2? This is a kite. They are congruent. Because take a look. They're formed by the two non-congruent sides. So 1 and 2 are congruent. All right, how does that help me, though? All right, hey, it's saying a kite is still a quadrilateral. How many total interior angles do I 4 interior angles, but what are they all add up to? 360. So you have 360 equal to the 101 plus the, was that 48? Plus the two angles that are congruent. Okay, let's keep it going. So angle 1, congruent to angle 2. What do we end up here? Yep, it's going to be a decimal here, I know. Can you do it? Of course not, 80. Six, what do you got for me? 2.4? Really? What are we adding up here, Grace? 101 plus 48, and then subtract it from 360, divide by 2. 105.5 degrees. Yep. Good. Everyone else, all right. Okay, here we go with number 2. We should be able to find it. I know we're just brand new to these properties, but look back. What's angle 1 right now? 90. Diagonals are perpendicular. So if that's 90, that means all those angles are 90. So I should be able to find angle 2 right now, since there's 180 degrees in every triangle. And we should end up with what for angle 2? 5. What do you got? Yep, you got it. 63. All good. Now we just got angle 3 hanging out there. Angle 3. How can we get to that? Maybe not using a kite fact, but maybe using this fact right here, everybody. Look at this triangle right here. What type is it? Isosceles. What's across from the congruent sides? Congruent angles. Both of them are 2 and 3. We already know 2, so 3 also has to be 63. Good. Which, if you want to keep, and I don't want to overload you with these properties. If you wanted to keep going, though, doesn't this diagonal bisect the angles too? Because that'll be 27 and 27. All right, so I don't want to overload you, but that's true as well. And then finally, 3 here, because I don't think we'll get to the graphing one today. Oh, boy. Look at this one, huh? The 8x is that angle measure right there. Not the whole angle, just that angle measure. So, any thoughts on how I can solve for x here? Ended on a strong note. Any equations you want me to set up to try to find x? Hi, Vincent. Okay, so you're saying this is isosceles, right? So that must be 8x over here. All right, we just learned, all right, that diagonal bisects, so this angle right here is also 5x minus 1. Add them all together to 180. That's fine. Another way we could have done this, take a look. What do you know about the diagonals of a kite? They are perpendicular, so that forms a right angle here. And we know that's 8x because it's isosceles, so I could add those 3 up and set it equal to 180. Either way is going to work. Okay, either way should work. And whenever you're ready, finish this class off strong. Let me know what you got for x when you're ready. 22, going deep. $22. Give him some quiet. Don't help him. Give him some quiet. He's got 30 seconds. I should tie the homework into this, huh? If he gets it right, we're good to go. If not, you've got to go back on it. We're down to 10.
7.
We sure about that?
Yes.
Enjoy the no homework.